Hi everyone and welcome to Research Simplified. I'm Professor Phoebe. I have a master's in molecular biosciences and a doctorate in public health, specializing in research methodologies. I'm here to share with you bite-sized insights, practical tips, just to help you make sense of this weird thing called research. Welcome back. Today we are talking about a powerful and sometimes tricky statistical concept, the p-value. Whether you're reading the news report or searching for the next big medical breakthrough, you'll see scientists use p-value to see if the results are real or just random coincidences. However, just because your p-value is less than 0.05 and therefore statistically significant, it may not mean that it is actually meaningful and applicable to real life. I'll explain more in this video. Alright, the P in p-value stands for probability. A p-value is basically a number that comes out of various statistical tests that tells researchers if what they are seeing is a pattern or if it's just some random coincidence. If it's a pattern, it's something that will most likely repeat itself and possibly something that we could predict. Triangle. If it is random, then it won't repeat itself and we wouldn't really be able to see what's going to come next. I really can't tell. Here's an example. Let's say both you and your friend each roll a dice. It lands on a 6 for you and a 2 for your friend. Is it random or will it become a pattern? Obviously, there's not enough data to say for sure. Let's continue with the scenario and say that both of you roll your dice 10 more times each. You get a 5, 2, 3, 4, 1, 6, 7, 8, 9, 1, 2. Your friend, on the other hand, lands on a 2 consistently every single time, 10 times in a row. For you, based on the results, it seems totally random. Your friend, on the other hand, does not seem so random that they've been rolling a 2 every single time, 10 times in a row. And so let's say you're starting to have suspicions of your friends, but you're not totally sure how accurate your suspicions are, or are you just overthinking the whole thing? That's when a p-value comes in. It's a piece of mathematical evidence that either supports or rejects the pattern that you are seeing. Is it random or is it a pattern that we should further investigate on? When it comes to reading p-values, researchers almost always use a cutoff at 0.05 or 5%. If your p-value is below 0.05, then it is considered statistically significant. That is a challenging thing to pronounce. It's a sign that what you found is probably a pattern and not completely random. But like most things, there's a big catch when it comes to using p-values. Sometimes scientists can look at a ton of data or test lots of different ideas, and just by chance, they find something that is statistically significant. This famous problem in statistics is called p-hacking. The more tests that you do, the higher the sample size, the more likely you're going to find results that look real, but is actually pure luck because with a sample size so large, you're bound to find something. An interesting book to read is Tyler Vigen. I'm just going to go with Vigen for now. Please let me know if I'm pronouncing it wrong. Vigen's book on spurious correlations pokes fun of random but statistically significant patterns in data. Like how the number of ice cream sales are associated with the number of shark attacks, and how the number of Nicolas Cage movies are somehow correlated with the number of pool drownings in America. Nicholas, why? In his book, he warns us that any sufficiently large data set will yield to strong correlations completely at random. That means statistically significant numbers can pop up even if there's no real relationships. Because of the way p-values are calculated, the larger the sample size, the lower the p-value. Now you're probably thinking p-values are completely useless because there is no way that the number of Nicolas Cage movies could affect pool drownings. While there are pitfalls and ways to misuse the p-value, there are also correct and useful ways to use the p-value. Here are some ways to use p-values to its fullest extent. Use other stats too, like the size effect or the confidence intervals. I will make a separate video on confidence intervals in the future. Yeah. Don't just look at the p-value, check if the findings even make sense and whether or not it has real-world impact. You can do this by conducting a literature review, piece it together, be a detective. Last but not least, aim for meaningful answers. Don't stop as soon as you see that the p-value is less than 0.05. Continue searching. Continue to figure out, does this finding make sense? If you're confused by now, just remember the main takeaway is that small p-values don't tell you that the results matter in real life. But it does point into the direction of where we should go next as researchers and how do we frame our findings. To wrap it up, p-values help scientists figure out what's probably real and what's probably just pure luck. And remember, they are just one of the many quantitative research tools out there. Last but not least, read other studies. See what other people are doing and what the current info is and how your study can fit into this vast clump of knowledge that's floating around everywhere. Don't just ask, is it significant? Ask, is it real? Does it matter? If you like this breakdown and want more simple explanations of scientific methodologies, hit like and also hit subscribe. Let me know in the comments what you want to learn about next. All right, bye.